Okay, so welcome to. I am a student of planning and GIS. Okay, so in today's video we are going to create NDWI map. How to calculate NDWI, Normalized Difference Water Index. This is a particular index that was proposed by MC McFeeters in 1996. It is a remote sensing index that is designed to enhance the detection of open water features while suppressing noise from soil and terrestrial vegetation features. So basically we use this to actually detect water bodies. Yes, we have Normalized Difference Vegetation Index NDWI that we use to detect vegetative cover of an area. We use this to actually detect the water bodies of an area. There is actually an older version that is called MNDWI. You can check that one out. I have a video on that one, so you can check it out. MNDWI, that one came before this one. Yes. So without wasting much time, the requirement is that you need, for the band 7, you need the bands for Landsat 7. For Landsat 7, you need bands 2 and band 4 to actually create this. Do you get it? So when I go to my ArcGIS, I already have my band 2 and my band 4, and I want to draw your attention that in case you are using band Landsat 7 and you are getting a scan line on it like this one, if I zoom in, you see that there will be scan lines on them. Do you get it? Have you seen the scan line? Yes. And I was able to actually remove the scan lines. So if you want to know how to remove Landsat 7 scan lines, you can watch the video. That is the link up there. It will take you through. So now let us go straight. The formula is that band 2 minus band 4 divided by band 2 plus band 4. So you go to Arc2 box. You go to Arc2 box. Then you go to Spatial Analysis to Map ArcGIS Raster Calculator. So once again, band 2 minus band 4 divided by band 2 plus band 4. But before that, we need a conditioner, which is called float. So float band 2 minus band 4 divided by another float, band 2 plus band 4. Do you get it? So I could have specified where I want it to be saved, but because of time, I'll just click OK. So NDWI is here. So that's the new raster over here. So I can go here, NDWI. Are you getting me? So when you look here, it is saying that positive values typically indicate water. Negative values indicate non-water features. So if you come here, you see that the positive value is the whitish area. Let me come here and choose this. You see that the positive values is the green area. So here is a water body, here is a water body. It is not surprised because the sea, the Gulf of Guinea, that is at the southern part of Ghana, this is it. So it is not surprising that it is a greeny area. Yes, it is indeed a water body. So this particular index is actually accurate. Are you getting me? So now, to do the analysis, let us narrow down to the study area. So I can go to this place and look for my study area. So this is my study area. Yeah, Densu Delta. So Densu Delta Ramsar site. So I will go to here, then I'll search for clip. You go to search, then you search for clip. It will come clip data management. The first one will be the raster we just calculated. The second one will be your boundary. Then you click OK. So let me uncheck this. Now we are having this. Do you get it? So at a larger area, we saw that here was a water body. Now we are here. It means that all this area is a water body. All the green areas are water bodies. We can actually compare it to a map over here. Have you seen here? Okay, we are actually using 2005. There is a land use land cover map I prepared for the area, and you see that here is a water body. So if you compare it here, you can see that it is following the pattern. Are you seeing it? Yes. Now let us do something. They are saying that when you look at the range, normally it ranges between -1 to +1. But if you come here, our range is between -0.07 to +0.5. So it is not following the pattern on paper. But then if you come here, it says that if it is less than -3, then it means dense canopy vegetation. If it is greater than 2, do you get it? It is the open water. So from the highest to the lowest, even though ours is not ranging from -1 to +1, we can use it and follow the pattern. It means our highest value is open body, rivers, lakes, reservoir, followed by low reflectant surface, shallow water, wetlands, followed by bare soil, built up surface, followed by dense vegetation. Are you getting me? So let us go and do this. You right click, you go to properties, you go to symbology, classify. Now how many classes? 1, 2, 3, 4. So we can come here, reduce it to 4. Do you get it? You can go to classify, then reduce the decimal places. Do you get it? Now if you have it like this, now our highest value is here, our lowest value is here. Do you get it? So if they are saying the highest value is open water, that is open water bodies, definitely open water bodies, then we can just color here water. Are you getting me? The next one is shallow water, wetlands, very moist soil. Okay, we are moving from descending order. Do you get it? So we can just come here and color this one too like that. The next one is what? Bare soil, built up surface. Let us assume it is a built up surface. And the next one, they are saying dense vegetation. You can go there and make it dense vegetation. Okay, now we are having this. Let us go and compare it to the map I prepared. 2005. Have you seen that it is following the pattern? Have you seen that? It is following the pattern. The waters are here, and the waters are there too. The vegetation is here. Vegetation is there too. The built up are there. Are you getting the concept? Yes. So since this and this are all water, we can even go back and combine this and this. You right click, you select the two, then you group them. Or if the grouping is not there, you can just color this one too, so that they become the same color. Do you get it? Yes. So the analysis we did is actually accurate. Do you get it? We've been able to detect the water bodies of the area. So instead of doing the land use land cover map, it is not in line accurately like that, but at least we've seen that it is similar. Are you getting me? Yes. So instead of doing land use land cover map, you can actually do NDWI map to detect water bodies of an area, if that is what you're actually interested in. Yes. So you can check the NDWI too. This is also another way you can detect water bodies, and I also have a video about how you can generate rivers. You can delineate rivers from digital elevation model. You can check that video too out. Yes. So thank you very much for watching, and I would like to see you in my next video. Bye bye.